In this video, we're going to say carrier distributions. In fact, it is minority carrier distributions in BJT in all modes of operations. I've taken here the PNP transistor where this potential is VEB and this potential is VCB, which means both the junctions are forward biased. And next, let's say if VEB is positive and VCB is negative, this we said is active region of operation. And if VEB is negative and VCB is positive, we said this is inverse active region of operation. And when both the potentials VEB and VCB are negative, this we said is cutoff. Now let me take VEB and VCB as two axes and show a two-dimensional plot. We can take this axis as VEB and let's take this one as VCB, where this is positive this side, negative here, and it is 0 here. And same here, that is VEB is positive here, 0 here, and negative here. Now looking at this table, we can say this first quadrant is saturation, and the second quadrant is active, and the third quadrant is cutoff, and the fourth quadrant is inverted or inverted active. In active region, the emitter junction would be forward biased, hence the depletion region width is small, and the collector junction is reverse biased, hence the depletion region width is large. Equilibrium minority carrier concentrations would be like this, but under biased condition it would be like this, where this is electron concentration, this is hole concentration, and this is electron concentration. We have seen this carrier distribution very well in the previous sections. Now coming to saturation region, both the junctions are forward biased, hence the depletion widths would be small at both the junctions. Equilibrium minority carrier concentrations would be like this with the dotted line shown here, and under bias condition we would have the carrier concentration in the emitter as similar to that of active, and in collector region, as this junction is forward biased, there would be a higher concentration of electrons at the junction, and as they go deep into the collector they get recombined, hence the carrier concentration would decrease. When we come to the base region, where the injection is happening from both emitter side and collector side, there would be huge carrier concentration in the base, which would be high at this point and even at this point, but of course it would be comparatively less in the base near collector region because of the doping differences. Hence the carrier concentration would look like this in saturation region of operation. Now coming to cutoff region, both the junctions would be reverse biased, hence the depletion region widths would be higher on both sides. Now as these are reverse biased, the carrier concentration, minority carrier concentration near the junction edge would be 0, hence the distribution would be like this on emitter side. Similarly on the collector side as well. In the base region, near these depletion regions, it should be 0, and as the width is very small, the carrier concentration would be almost 0. Now coming to the inverted region of operation, where emitter junction is reverse biased and collector junction is forward biased, hence the depletion region at the emitter junction would be higher and the depletion region at the collector junction would be smaller. Equilibrium minority carrier concentrations would be like this. As collector junction is forward biased, there would be electrons injected from base to collector, hence there would be some concentration here. As the electrons go deeper into collector, they get recombined and the carrier concentration would look like this. This is electron concentration in p-type material, that is in collector. there would be injection of holes from collector to base, hence there would be carrier concentration here, and it would reduce to zero near the emitter junction depletion region. The carrier concentration would be like this. And as the emitter junction is reverse biased, in the emitter side, the electron concentration would be like this, because the carrier concentration should be zero near the depletion region. Overall, we have seen how the minority carrier distribution would be in different regions, say emitter, base, and collector, in different modes of operations,